In this section, we want to expand on our discussion of limits to talk about how we answer limit questions related to behavior around vertical asymptotes and at the end behavior of a function. To start off, we'll look at finding limits at vertical asymptotes for a function. As a quick review, a vertical asymptote is a vertical line, which is indicated here by that dashed line in red. It's a vertical line that the function never crosses over. It has some break there. It approaches it from the left, approaches it from the right, but those two directions get closer and closer without ever actually intersecting with each other. In this case, we're looking at what's happening as x approaches 3. So we could look at highlighting that for ourselves, but that's already kind of indicated for us with this vertical asymptote. So as x approaches 3, we want to talk about what's happening as we approach from the right. Similar to how we did this previously with limits, we can trace along that curve and approach that x value of -3. In this case, we see that that curve keeps heading down and down and down towards -infinity. So we would say that the limit as x approaches 3 from the right-hand side is -infinity. As we approach from the left-hand side, we have that same behavior. We're approaching from the opposite direction, but we're still headed to -infinity. We apply the same idea that we had before. We look at the two one-sided limits. In this case, those correspond to each other. Both are -infinity. So the limit as x approaches 3 for this function will be -infinity. But the function itself, f of 3, the function value, is undefined, or we could say d and e does not exist. What's interesting to note here is that for a limit to exist, based off our definition of the limit that we introduced before, the limit actually has to be equal to a number. So this is kind of a side note, but in each of these cases, really the limit does not exist. The limit of a function only exists if it's approaching a number, but we go ahead and use this infinity notation anyway because it gives us more information about the behavior of the function. It's different here to say that the limit is -infinity or to say that the limit does not exist because it just tells us more about what's happening with the curve. But kind of keep that in the back of your head. These infinities really mean the limit doesn't exist, but it's a notation we use to communicate more information about the curve. In example 2, we want to consider the same concept, but now we're considering what's happening around x equals -2, or as x approaches -2. We'll consider the behavior as we approach from the right. In this case, that curve is just going to keep going up and up and up to +infinity, but as we approach from the left, we're headed down to -infinity. In this case, the one-sided limits are different from each other, so we would state here very clearly, d and e does not exist. Again, that's different than what we did in example 1, because the one-sided limits were the same. Even though the limit doesn't equal a number, we use that infinity or -infinity notation to tell us the difference between, in this case, example 1, the curve is heading down on both sides of that asymptote, versus in this case, the curve is heading in opposite directions of that asymptote. So it's just revealing more information about the behavior of the graph. And then again, g of -2 would be undefined or does not exist because a function is never defined at a vertical asymptote. In example 3, we're asked more or less the same question, but now we're considering more than one x value. So for the first 3 parts, we're considering what's happening as x is approaching 2, and for the last 3 parts, what's happening as x is approaching 7. So as x approaches 2 from the right-hand side, we see that our function value is headed to positive infinity, and we have that same behavior as we approach from the left. So the one-sided limits will both be positive infinity, meaning the limit as x approaches 2 for this function will be positive infinity. However, when we look at the behavior as x approaches 7, we see that from the right, our function is headed to negative infinity, while as we approach from the left, we're headed to positive infinity, meaning that the limit as x approaches 7 in this case does not exist. Again, telling us the difference between the curve heading in the same direction as it approaches that asymptote from both sides, or heading in opposite directions.